For an example, no? So we have here a composite wall. So composite wall is just a wall with different layers. So you can imagine a wall with concrete, with insulation, and gypsum boards. Realistically, it happens, no? So in this case, we have a brickwork with this thickness. You have fiberglass or insulation with this thickness, and then another insulating board, no? And then you have the given thermal conductivity of these three materials. Okay, and then you have also the convective coefficient, no, of the surfaces, of the inside and outside walls. Then you have the given ambient temperatures of the internal and external portion of the wall. So we want to find the thrust of the wall of a 6 meter high and 10 meter long wall, probably, no? So how do we solve for this? No? You can imagine first the problem. So you have, let's say, this is the wall. Sorry, so this is like, for example, the wall. So you have here, um, let's start with outside, no? Which is the hotter one, outside or the internal. External is the hotter, no? So you have 27 degrees here, external. So you have your brick, no? Brickwork for the first layer. And then for the second layer, you have a layer of fiberglass, fiber, glass. And then you have another layer of insulating board. So insulating board. Okay, so you have these three layers, and then heat will go from hot to cold, no? So this will be the temperature, and then heat will transfer to this direction. You have Q here. Okay, now thermal conductivity are given, the thicknesses are given, right? Also the H are given. Also, we have here an H O outside, and then you have H in. You have the thermal conductivity of the brick, the fiberglass, and also the insulating board. No? So the length are also given. So we can find the length. We have LB, you have here LF, we have LIB. So I won't write this anymore, guys. So the solution here is to really treat this as an electrical circuit, no? Or an electrical element. No? So you can imagine this is 27 degrees Celsius. And then you have a resistive element for conduction. Sorry, convection, which is 1 over HOA. Okay. Okay. And then you have here another resistance for the conduction of the brick. So you have L over KA of the brick, right? Okay. And then another one, you have the fiberglass. So the resistance of the fiberglass is L over KA as well, which is fiberglass. And then the last one, for the materials, you have also the insulating board. Ins board, no? And then the last one will be the convective heat transfer, which is 1 over HI A. So to find the total resistance, no, of this, you can just add, no? You just add this to find the total resistance, which is our total, right? And we can solve the Q, or the heat transfer flow rate, which is equal to T. So this will be T outside, no? Infinity. So T infinity outside minus T infinity inside, and then over our total. Okay? So to solve for this, you have to first find the R total. And then we just solve this using this. So to find our total, just substitute the values here, no? So the area here is, since this is 3 dimensions, so I can imagine this is 3 dimensions. So the area here is 6 meter by, this is 10 meter, and then this is 6 meter. So the area here, actually you can factor out the area if you want, no? So I'll just do that, since all of this has area. It's an area, it's the same area for everyone. So just factor the area, and then you can just solve for 1 over HO, and so on. So the area here is 1 over 6 times 10. And then the 1 over HO, so we have 1 over HO. So the external or the outside pole is 2.5. And then you have plus L over K. So I'll just remove that area here, because we factor out the area. So the L here, sorry, the L here is 110, so 0.11. Okay, this one. And then K here is the thermal coefficient of the brickwork is 1.5. So 1.5. So L over K only, no? And then you have plus L over K for the fiberglass. You have 75 millimeters, so 0.075 meter all over this one, 0.04. 0.04. And then plus we have the last one, so insulating boards 25 millimeters, so we have 0.025 meter all over 0.06 watt per meter Kelvin. So I will not write the units anymore at this point, but you have to write the units if this is you solve this, just to make things brief, no? Sorry, we have one last. You have the convective coefficient, so we have 1 over 3.1. Okay, so the R total here is in your calculators. Calculate here. Okay, so you have 1 over 6 times 10, which is 60. And then times, you have 1 over 2.5 plus 0.110 over 1.5 plus 0.05, so 0.75, 0.04 plus 0.025 over 0.06, and then plus 1 over 3.1. Okay, so we close this. The answer is 0.00514. I'll just use 4 significant digits, 5146. So what is the unit here? So we can analyze the units here. So this is in watt per meter squared Kelvin. So this is in meter squared. So this will be watt per Kelvin. Okay. Sorry. This should be in this na nakabaliktad nga pala to. So this should be meter squared Kelvin per watt. So this should be Kelvin per watt. Okay. So this will be Kelvin per watt. So after that, what we can do here is to use this formula so that to find the heat transfer rate. This will be just 27 minus 10, okay? And then divide this by 0.05146. So this is in Kelvin, this is in Kelvin per watt. So the answer should be in watts. So if you divide this, so you have 17, then the answer. So you have 330.36 or about 330.10. So 330.36 watts. So this will be your heat transfer flow rate, no? In this one. Okay?